This lecture is about a new functional group, which is alcohol phenol. We are going to see how does this alcohol phenol looks like, how does it have their own physical properties, and acidity of alcohols. First, alcohol are normally used as rubbing alcohol, which is isopropanol. We can also have synthesized methanol for industry and synthesized ethanol from our fermentation of sugar and starches and fruits. So how does this alcohol looks like? It does have a similar structure with water. However, alcohol have an R substituent, which is a alkyl group. So on this alkyl group, you have one hydroxyl group called OH. So for this alcohol, there are going to be 4 classification: primary, secondary, tertiary, and aromatic alcohol. Please know how to differentiate the structures from each of the classification. For example, we are going to see some examples of primary, secondary, tertiary, and phenols especially. So notice where does this OH is on a carbon to make up its primary, secondary, tertiary, and a phenol structures. So naming for this functional group are the same as before. We are going to use the IUPAC system where you have to find the longest carbon chain, number the carbon chain nearest to the OH, so that the OH group must be the lowest number. Consider also other functional group or substituent on the main body. So please notice who is going to be first and who is going to be later, and then how you can want a number and alphabetical order. This slide shows a few examples of nomenclature. Please notice how it's written and how important is the numbers and ABC. So, for example, this one, even though the bromo B comes early than E, because of this OH is sitting at the right side, this must be the lowest number. So you have to number it from right to left, making the bromo sit at the carbon number 6. So in a ring also, you have to understand and notice where should the numbering goes. Is it anti-clockwise or is it clockwise? So that the OH have to be the lowest number, but then you have to have a lower number also for the other substituent, and possibly the lowest number. Have a go, have a try with these questions, and remember again, we will discuss this later. So the main priority right now, we have learned number 9, 8, 7, and now number 5. So you can see the most powerful or priority in the naming is alcohol. So alcohol must be the lowest number. Same goes with the phenol. Phenol is the main body right now. So who is on the phenol? We have to name it according to the lowest number. Or you can use the auto, meta, para position. To the physical properties, we have to compare these with something similar in molecular weight. So we are going to compare boiling point and solubility. For solubility here, in this diagram, you can see hydrogen bonding forming between alcohol and alcohol molecule. Comparing it with ether and ether, there are no hydrogen bonding form, so that solubility for ether decreases. Boiling point shows that it's either you can explain it due to hydrogen bonding or dipole-dipole attraction between these 3 compounds. You can see that between alkane, a normal hydrocarbon, ether, a dimethyl ether, and an alcohol, in this increasing order, you have the BP increase from propane, lowest, dimethyl ether, and ethanol the highest. So again, the solubility you can see here. When we talk about solubility, it is about water molecule attraction with our compound. So we have 3 H2O molecules having hydrogen bonding with our hydroxyl group at the end of this hydrophobic region. With this hydrophobic region, decreases in solubility happens when the alkyl group increases. Next is the acidity of alcohol. Even though it's an alcohol and phenol, it does have some acidity properties because of the protonation can happen. So these are some facts that you have to understand and read. So acidity is the pKa range between 15 to 18, and then acidity decreases as alkyl group increases. And then halogen also increases acidity. Comparing phenol with alcohol, phenol are more acidic than phenol. So you can see here the number, the main view here is when the pKa is higher, the acidity decreases. So this table just to compare a few. Take note for the normal compound comparing with methanol, ethanol, phenol, and water. You can see that pKa are so different from each other. So because of this acidity, these alcohol and phenol can react with base. So what kind of base can react with this kind of compound? Normally, when you have alcohol, we are going to react it with a sodium metal. When you have a sodium metal, what will form is an alkoxide ion, which is called RO dot dot minus. So the H plus is now cleaved, forming a minus charge on the oxygen. So this is an alkoxide. So for example, at the bottom here, you have ethanol react with sodium metal. What you will get is sodium ethoxide. So formation of phenolxide, it is more acidic than alcohol. You can actually react with sodium hydroxide. So what will form is a sodium phenoxide. When this hydrogen of the phenol is cleaved, it will be in a phenoxide form. So please read this part so that you can understand why is this phenolxide ion stable, because of the localization of negative charge via resonance. So when this acidity of phenol will have a decreasing and increasing factor by having other substituent on the benzene ring. So you have electron withdrawing groups. If there are some electron withdrawing groups on the phenol, the acidity will increase, and then if you have electron donating group, the acidity will decrease.